My name is Ronnie, and thanks everyone for following our first webinar on mastering film-forming amines. We will do this as a series with several topics over the next couple of months, and we hope to give you some insights from our 40 years of experience with the application of film-forming amines. And we will do a recording of that, so everyone will get a link or a file afterwards to download the recording of the webinar. And so let's start with a very short introduction of REICON to everyone who's not knowing us so far. So I hope everyone can see my screen, and we will go through it. So as said, we have more than 4 years experience in the application of ODA-based film-forming amines. We are now a family-owned company since 1992. Before that, we were working in a research institute to develop ODA-based applications for nuclear power plants. And since 1992, our products are available under the trade name ODACON. It's a film-forming amine product. We will come to that back later. And we are based in Germany, in Leipzig. We have our own service and laboratory team to support our customers with their application on site. And we have a network of well-experienced partners and distributors all over the world. So we are able to serve applications from New Zealand to Canada with our products. As said, we are coming from the nuclear power industry, so our products are still in use there. It's the only film-forming amine product which is certified for the use in nuclear power. We're having several customers with fossil units, combined cycle plants, biomass and waste-to-energy facilities, and very big amount of companies from all parts of the industry where boilers are in use, especially from the chemical and paper industry, but also building materials, pharma, and even food industry. We are dealing also with district heating networks and hot water boilers, and we have some special products for closed cooling systems with high restrictions on conductivity, for instance. So let's start with today's topic, which is basics and application guidelines. So we will look at what are those film-forming amines and what not, and how do they work, and which guidelines do exist, and what is the main content of those guidelines. So starting with the first section, over the last years, there was a huge differences in the names and the wordings and the terms of all the products which were available. And when it starts becoming of interest for power plants, there was a big discussion which terminology we can work with. And so we agreed on 3 things, and this is done mainly by the IAPs and supported by the IAPs, which created also a wide knowledge base on those film-forming amines. And when we talk about film-forming amines, we only talk about the active substance. And at the moment, there are 3 FFAs included in all IAPS documentations, which is octadiethylamine or ODA, oleulamine or OLA, or olesyl propylene diamine or OLDA. So when we're talking about film-forming amines, it's only the active substance which is meant by that. Then we have a second group, which are the film-forming amine products, and these are the commercially available products which contain at least 1 FFA. But it also can be blends of different 1 or more FFAs to achieve additional effects. And most of the products are mixtures with alkalizing amines, emulsifiers, sometimes dispersants. So they can contain volatile and non-volatile substances, which makes the application of those products and sometimes difficult depending on the dosage point. So if you look at the FFAP, you should always look at the composition of those products. And in the last years, there comes a third group, which is called film-forming products. And these are all commercially available products which do not contain one of those 3 FFAs, but also have film-forming effects. So most of those products are proprietary formulations, and it's not exactly known which kind of molecules are used in those formulations. And because of that, there's a very small scientific background available. And all these things together are called film-forming substances. So film-forming substances covers all 3 types of the film-forming amines, film-forming amine products, and the film-forming products. And especially when you do an application, you really need to know the full composition, which should be dosed to do a proper risk assessment and also a customization on the individual plant characteristics. So in terms of plant design, metallurgy, the chemical treatment which is applied, so that it all works together and does not cause any problems during the application. Here's a short overview, which I led from Barry Dooley and David Edison. They showed on the IAPS FFS Symposium in 2021, which shows a little bit the difference between the film-forming amine products and the film-forming products. And especially with the film-forming amine products, you see that there's also some difference in the composition of the product itself. So it could be stabilized by neutralizing amines. It could be emulsions, which are pure substances mostly. And in some cases, you have products which do contain neutralizing amines and additional polycarboxylates. We even see products that having oxygen scavengers in it. And so you really need to look what is the exact composition of the product to avoid any surprises during the application. To do some little bit of marketing, so our products, ODACON, are in the field of emulsions. So we do not add anything else to our products except the active substance. And also we have a very well research work done in the 1970s and 80s for all the things that are related to the application of ODA in nuclear, but also nowadays in fossil and HRSG applications. So there's a lot of literature available containing ODA as the film-forming amine which is used. So how do the FFAs work? So in the following slides, I will focus on the FFAs because we do not really understand how the FFPs are working because we do not really know what those FFPs are. So I will focus on the FFAs. And so the main active reaction is the adsorption process on the metal or oxide surface. So when you start the feeding of FFAs into a system, you have a distribution of the FFA molecules in the water or steam, and then they will attach to the surface by the physical adsorption between the different polar load of the molecule and the oxide layer. And so the film starts to form. In the beginning, it's a very loose and open layer, but with the time and the continuous dosing, this layer gets really dense, and the amine group is attaching to the surface by a chemical bonding of the amine with the oxide layering, and the hydrophobic group is oriented to the water phase or the steam phase of the system. And then if you continue feeding, you get a multi-layering. In the best case, it's a bimolecular layer, but could be even more, and which create a very dense and diffusion resistant layer on the top of the oxide, which prevents oxygen to enter to the oxide layer and stops forming corrosion active spots. As this is working in the whole water steam system, because all the FFA are highly volatile products, so we get it in the water and in the steam phase, and everywhere these formation of this protective layer takes place. And when it's absorbed by chemical bonding, the layer is very stable and also stays on the surface during offline periods. And when you drain the system, the double or multi-layering is removed, and you get this hydrophobic surface, which is visible mainly in the water-touched surfaces or wet steam areas, which shows a water repellency. And this is the main effect, because we use it during preservation of power plant equipment in offline periods, or for example in cycling units where you have a operation and offline periods shifting very frequently. And side effect of this adsorption is that especially porous oxide layers and also corrosion active deposits are removed slowly from the surface, and chlorides, for instance, are even removed from crevices. So you see here a picture from before the ODA treatment. In a power system, you see a very rough and porous oxide layer, and after the treatment, this is very smooth and homogeneous, and which also improves the corrosion protection. And on that layer, you get an additional FFA film, so which shows that the system is very well protected. With chlorides, we know that ODA is forming a complex, so it keeps the chlorides in solution after removing them from surfaces, and so it can be removed by blowdown from the system, and this can help also to protect against stress corrosion cracking, especially in the last stages of the steam turbine, when you get some boiler water into the steam. So this can help to prevent the issues with stress corrosion cracking. Another effect is the reduced droplet diameter. So the film-forming amines have a surface tension lowering effect, and so the droplet diameter is decreasing. And with these smaller droplets, you get a much smaller effect on drop impingement corrosion, especially on the last turbine blades. You can see an improvement of the surface roughness, and also flow accelerated corrosion is reduced. We know that from single as well as two-phase flows, where you have a reduction of the ion transport in the system, which is obviously seen also in the longevity of the equipment. With this comes a second effect, which is the reduce also of the water film in the condensation phase, up to a droplet condensation on the surface of the condenser tubes. And this reduces the insulating properties of the water film on that surface and can increase the heat transfer, and so save operational costs and reduce the water and energy demand during the addition of the film-forming amine. So coming to the second part, which is application guidelines. As said, before 2016 or before 2012, there was very low interest in those film-forming amines from the power industry, because they were mostly running on base load operation, and we only had a few applications in the power industry and mostly in industrial boilers. But then with the more and more cycling of plants and seasonal standstill, the preservation gets more and more in interest, and all the operators were looking for guidelines and help for the application. And so until 2016, there was no independent guideline available. So you have to follow the recommendations by the manufacturer. There were a lot of different wordings in the market: filming amines, polyamines, fatty amines. And some of them are still in use. And there was no differentiation between products and active substances and mixtures. And so it was really hard to get an overview on what is on the market and what is helpful and what not. So, and the IAPS started. So I don't know if everyone knows IAPS. This is the International Association of Properties of Water and Steam. And it's a non-profit organization dealing with several aspects of water and steam characteristics. And also there's a group in that IAPS called Power Cycle Chemistry. And this group was starting to deeper investigate in those film-forming substances, and which lead to the release of the IAPS technical guidance document 816 about application of film-forming substances in fossil, combined cycle, and biomass power plants. And this was the first technical guidance ever, which were created by operators, by suppliers from film-forming substances worldwide, and all put together their knowledge to build up a strong database and recommendation for the application of those products. And it's already get an update in 2019, so it's still in progress and work, because the knowledge is increasing. A lot of research is still done, and which will be included in the new revision of the TGD. Also, now 2019, there was the release of the IAPS TGD 1119, which is about the application of film-forming substances in industrial steam generators. There is no big difference in the first general informations, what is mentioned in chapter 1 to 7. But of course, there's some differences in the steam generator designs and the use cases. So there's a higher focus on customization in the chapter 8 and 9. 2023, the revision of the VGBE standard S10 was published. It's about feed water, boiler water, and steam quality for power plants. And there, for the first time, the film-forming amines are included as well, but with a reference to the IAPS TGD. So most of the information which are contained in the VGBE standard, you can find in the TGDs, and sometimes in a little bit deeper way. So that's why I focus on the two IAPS TGDs, so which is providing a lot of background information, also some guidance what FFS can be applied, in which situation, which tests are required, dosage levels, and how to analyze those products. The structure of both is really similar. We have the first two sections with our general information, how to use the IEPS TGDs. Then we have a section with general information on those film-forming substances, the pros and cons, the general effects. And a big part is operational guidance and customization with different application cases, analytical procedures, and plant-specific customization, depending on the metallurgy, if a condensate polishing plant is used or air-cooled condensers. And if we look at these two sections, we have a base case definition in Chapter 8, which is an all-ferrous fossil combined cycle HRSG biomass plant for the TGD 816, and all-ferrous industrial steam generator with a steam turbine and without condensate polisher in TGD 1119. And those base case gave a guideline on the selection which FFAs can be used, depending on plant characteristics, health and safety aspects, qualification of the supplier. Also, it gives recommendations for the baseline monitoring before the start of an injection, which dosing points are possible, and which dosing equipment is necessary in terms of flow rate, pressure, and location of injection, and how to measure the FFAs concentration. So these are the sub-chapters, so we go over this, because what is also very important is Chapter 9, customization, and even there is a general overview of the plants, you need to do an individual look at your plant, and you cannot apply the same procedure each and everywhere in the world. So that's why there is a big part on customization. When we see here, also the difference of the TGD 816 and 1119, especially for the TGD and industrial plant, there's plus 10 pages on customizations because of the several aspects the steam can be used for. In Chapter 9, we have 10 sub-chapters which are similar in both TGDs. It's about selection of the right product and according to the plant application. Also, look at the differences because of the formulations. Are there non-volatile components in it or not? What are the difference in terms of material compositions, or are there aluminium materials in the system or copper-containing condensers? What effects does this have on the treatment? What about cooling systems? So are there air-cooled condensers in the plant or seawater cooling systems? So what has to be looked for there? Is it a non-continuous use for a short-term application like a preservation? And then you have additional content in the industrial TGD, which looks especially on boiler types, so large water boilers, reboilers, steam generators, so different types of boilers you can find in industrial plants. Also the makeup water quality, so what effect does softened makeup water has? What is about organic contamination in the makeup water? Yeah, what about sensitive use of steam in the mean of food production, milk and dairy products, as all the products are steam volatile? You need to look at this, especially when you have those types of sensitive use of steam. And a special part on especially steam crackers and petrochemical industry, where the steam is used in other sections of the process as well, and what effects can the film formers have there. So coming to an end, so film-forming amines are nowadays a well understood and accepted chemical treatment program for power plants and industrial boilers as well. if they are applied correctly, they have a lot of benefits, especially when your plants are cycling or you do a preservation. With the IAPS TGDs, we have an independent and international accepted guideline for those applications. And they can help to give some assistance through the jungle of various products which are available on the market to choose the right one. And it's a very comprehensive summary of the state-of-the-art knowledge from suppliers, from scientific researchers and operational experience. And the best thing is all IAPS TGD are freely available on the IAPS website. So you can download them and find a lot of more information there as well. So I say thank you for listening. And if you have any questions, just raise your hand and maybe we have a few minutes time to discuss. If not, just write us a message on LinkedIn or by email, and we will answer that for sure. And also I want to give the information about the next session, which will be on July 10, 1 p.m. again, and we'll deal with different analysis procedures to measure film-forming amines in the water steam cycle. Okay, so I see a question here from Giuseppe. We will unmute you and or
Hi, Giuseppe from NCH Italy.
hello.
It's been nice to be here and hear a little bit more because as water treatment company, we are going to approach this kind of technology. So I'm quite interested on it, but especially for cooling system, is that sounds new for me. So if you can spend a little bit, few more words about it, we'll be glad to hear you about that. Thank you.
For cooling systems, we mainly use our products in closed cooling systems because there we have mostly a good water quality and a good we can build up the layer and just do a periodic follow-up treatment. I know that there are other products on the market which contain FFAs for closed, for open cooling systems, but we never used it in open cooling systems because of the evaporization. We lose a lot of product, and also the temperature is a little bit low normally for forming a long-lasting film on the surface. So that's why we normally only focus on higher temperature systems. But I know that there are products on the market, mixtures which contain several products in cooling water systems, and which also have film-forming amines in it.
Okay, thank you very much. But just one more. But and what's some regarding some? You talked about the benefits of film-forming, but if some limitation, some restriction.
Yes,
there are some
depending on the applications, you can have some restrictions in terms of health and safety aspects, in terms of depending on the product, in terms of the compatibility with the existing treatment programs, and also what is true for all film-forming amines is that you get an increase of the cation conductivity in the steam, depending on the concentration, but it is normally that you will increase your conductivity of the cation exchanger a little bit, depending on the amount or on the concentration in the steam. because it's an organic molecule and it undergoes a thermal degradation depending on the active component and on the mixture as well.
Okay, thank you very much. Appreciate it.
Yeah, you're welcome.
Ronnie, can I say something? Ronnie?
Yes. Hey, Danny.
Yes, hi. Just to say thank you very much, and to all the participants. We are the Israeli distributor, and we have very, very good experience with ODACON products for the last few years. And thank you very much for the interesting session.
Thank you. Thank you, Danny. All right. Terence, you raised your hand. Terence, we can't hear you. Maybe you can write it in the chat, so we can't hear you. Sorry.
I have raised some questions in the chat. Can you just go through, Ronnie? Yeah.
Yes, I have a look. We know that in terms of the question is how FFAs are helping to reduce FAC. Thanks, David, for adding a comment. We know, especially in the water phase, that due to the formation of the layer on the surface, that we reduce the iron release and the corrosion by adding the film-forming amine to the system. And from the research we did in the 80s in the large steam turbines of nuclear power stations, we know as well that also in the wet steam areas, there is a decrease of the flow accelerated corrosion due to the effect that the water droplets which hitting the surface and causing the damage are smaller, and so the effect of those is less. And at the same time, as the amine is also on the face of the outside of the steam bubble, you have a slightly higher pH directly on the surface of the water boundary phase, and which also helps to increase the FAC protection.
Why EPRI has not come up with FFA till now?
I haven't understand that correctly. Could you please?
EPRI, I think you will be aware about EPRI, Electrical Product Research Institute, America.
Yeah.
US based, because we in India follow EPRI guidelines more than VGB. Okay, VGB earlier, before 2002, we were going behind, going with VGB guidelines, but now we are more of with EPRI guidelines, and we follow EPRI guidelines. And in EPRI guidelines, they have clearly written that anything other than hydrazine, ammonia, or TSP, wherever TSP is used, is actually going to cause harm, more harm than a good thing in the system. Should I rephrase the question again?
So we are working with the EPRI in some research projects for nuclear applications mainly. because we do not have a customer base in the US at the moment. And especially with the guidelines from whether it's EPRI or VGBE, they are very, very slow in taking new developments into their guidelines. And it's taking a very, very long time of discussions to do that. EPRI has done some testing with other FFA or FFP products in the past, and I know that they have published some reports on that. When they will add this to their guidelines for the water quality, I don't know.
While talking to the CEO of VGB, Mr. Christian Ulrich, I didn't get any hint from him that I can use FFA in the power plants or in petrochemical areas. Because he was here, he was working with me, the CEO of VGB. So
maybe he doesn't know.
Mr. Christian Ulrich is the VGB
Yeah, I know him. I know him.
Chief Executive Officer. So
yeah, I know.
He worked with me for 7 days here in India. But I don't know. He never asked me to, look into this FFA. I think I need more information on FFA from you. You are already having my email ID with you, but that is my personal email ID. Okay. You may reconnect me on my personal email ID, and then we can discuss more about it. One question, very important, that do you have any Indian distributor yet?
No.
Okay, then I may be the first one.
Perfect.
It's
just we stay perfect. I will contact you afterwards by email.
Okay. My master from whom I learn many things, Mr. Ashwin Kumar Sinha, is also there in the group listening to you.
Okay, perfect.
Yeah.
Thank you very much. So there are still some other questions about the measurement of the residual. So we use a photometric measurement based on methyl orange. So we have a method for that. But again, next time we will speak in detail about the different possibilities to measure FFA in the water steam cycle. There have been some developments in the past. It's now also possible to have an online monitoring of specific products. So we will talk about this on July 10. And another question, can they use to replace hydrazine in cooling water systems? This is different to answer because it's a completely different aspect, because hydrazine is acting as an oxygen scavenger, and this will not be happening with film-forming amines. They are corrosion inhibitors, let's say, and so this will be very difficult to handle.
Absolutely, the purposes are different for both of them.
Yeah. And another question from Alper: can the transition period or conversion to conditioning system no, I don't think so. I don't think the conversion can be done within a 1 day, because normally you start adding very, very small amounts to give the system time to react, and it's depending on the plant design and on the temperature and everything, but I think at least it will take a few weeks to do a full conversation.
One small question, Ronnie. This FFA is going to affect anything? Is it going to condense first, or is it going to condense last? Like CO2 condenses first before water. So this FFA will condense with CO2 itself, or it will.
No, it will condense later.
Okay, so I have to remove CO2 first from the water before, because the turbine blades normally I've seen those who use morpholin and carbohydrazide even, they suffer of CO2 corrosion in turbine. So there the FFA will not help me so much. I have to first remove the this thing. And what is the distribution coefficient of this FFA?
It's
This is very
similar
important for me.
it's similar to ammonia.
1:10?
Like
1:10?
Yeah.
Oh, so I can't do away with phosphate also in this case. Means if I'm on PT, if I'm on phosphate treatment, then can I do away with phosphate treatment if you mix
No,
this?
so this is depending on the product on the FFA product you're using, because this is depending on the formulation you have. So if you have something in the product which is doing the alkalization, then maybe you can replace it. But especially with our product, which is a only film-forming amine component, it is just an add-on to the existing treatment. So you can reduce or remove hydrazine after a while, but in general, we use it as an add-on to the existing treatment program.
Hydrazine does not need to be removed, because hydrazine acts as a different, its reaction rate increases, the Shikor reaction rate increases in presence of hydrazine. Hydrazine is important, but we can reduce the PPB levels, residual PPB levels.
So as said, you need to choose the right product and have a look at the full composition. Yeah.
Filming amine will be more helpful for me in the return line, I think, from the condenser to the deaerator and up to the economizer.
Yeah.
Okay.
So, yeah. Okay. So one last question from Terence. Yeah, this is a good question. How can we test if the application is working or not? There are several ways of doing that. You can during operation you can monitor your iron concentration in the blowdown and in the boiler water, or in other areas where you're looking at. And also maybe hydrogen production in terms of if there's a corrosion process ongoing. The second point is you can do an inspection afterwards and measure some corrosion resistance on the surface, which is quite difficult to do, but you can do that. There is a visual effect in some cases where you see this hydrophobicity, but this is an ongoing discussion if this is a test for the corrosion protection itself or not. You can clearly see a change, but not in every section. This is a proof of the protecting effect, and or you have to place some coupons in it and test them afterwards. So thanks, David. All right.
One last question. One last question from me.
Okay, last question.
Yeah. Can I recommend your product in supercritical units?
We have at the moment no plant with supercritical conditions running. So honestly spoken, I don't know.
Okay. So please connect me back on for the commercial things and other things, so that I can be your useful partner in India.
Of course. Thank you.
Thank you.
So, thanks everyone who joined. Follow up and also join our next webinar in July about the analytics. And if you have any questions in the meantime, just send us an email and we will answer this as soon as possible. So thanks everyone and see you next time.
Thank
Thank
you.
you. Thank you
Bye.
so much.
Thank you.
Thank you so much for the information. I really like to have you here.
Thank you. All the best. Bye-bye.
Bye.
Mm.